you can open the inserted, okay, and inserted P block chapter 7, that is unit 7 P block, and the book edition should be, I think, 2020. In 2020 edition P block is present, but when the new editions is actually published, from that time P block was removed. I think now also P block is not there in a new edition, so you can buy the old edition of books for P block. Let me see what is my edition of the book. Oh my god, what happens? Yes, my edition book is 2019. So in the old edition you will find P block, but in the new edition you will not find P block, because in board examination also P block is deleted. Okay, but in NEET you will find this P block chapter. You can open the page number 170, and let me open the page number. So I am reading inserting now. The P block elements. Okay, so the objectives are given. After studying this unit, you will be able to appreciate general trends in chemistry of elements of group 15, 16, 17 and 18. So after reading this chapter, what we can understand? We can understand the general trends in the chemistry of elements of groups 15, 16, 17, 18. So I am reading the P block elements of class 12. Learn the preparation, properties and use of dinitrogens and phosphorus and some of the important compounds. I think this thing is deleted in it. So describe the preparation, properties and use of dioxygen, ozone and chemistry of some simple oxides. How allotropic form of sulfur, chemistry of important compounds and structure, the structures of its oxo acids. Describe the preparation and properties and the use of chlorine and hydrochloric acid. Know the chemistry of interhalogens and structures of oxoacids and halogens. Enumerate the use of noble gases, okay, and appreciate the importance of these elements and their compounds in our day-to-day life. So these things we can know from this chapter, means unit 7, and the chapter name is the P block elements. In class 11, you have learned the P block elements are placed in group 13 to 18 of the periodic table. So obviously the P block elements are from group 13 to 18. The valence electronic configuration is N(S)2. N is the principal quantum number. So N can be 1, 2, 3, 4, 5, 6, 7, like, yes. So you can hear N(S)2 and Np 1 to 6. N(S)2, here 2 is the electrons and Np 1 to 6. So p orbitals. So S is the orbitals, p is the orbitals. So for S there will be two electrons can be fitted in s orbitals, and in p orbitals 6 electrons can be fitted in p orbitals. So that's why it's written that np2 and np1 to 6. Except helium, which has ns2 configuration. So except helium, all have configuration ns2 and np1 to 6, but helium configuration is ns2, so it is the exception, but helium is placed in p block only. The properties of p block elements, like that of other, are greatly influenced by atomic size, ionization enthalpy, electron gun enthalpy, and electronegativity. This means that the properties of p blocks of elements, like that of others, means rather than p block elements, the other elements of s block, d block, and a block, they are also influenced by this property. Similarly, p block also influenced by these properties, and the properties are atomic size, ionization enthalpy, electron gain enthalpy, and electronegativity. The absence of d orbital in the second period, so there is no d orbital in the second period, and presence of d or d and f orbitals in heavier metals. So d and d and f orbitals are considered as heavier metals, and they are the heavier transition metals. Then there are non-transition metals also, and starting from third period onwards. So in second period there is no d orbitals, but from the third period onwards you will find there will be presence of d and f orbitals. Okay. So line is there, written like this: the absence of d orbitals in second period and presence of d or d and f orbitals in heavier elements starting from third period onwards, having significant effects on the properties of element. Okay. So due to this, means due to absence of d blocks in second period and presence of d and d or d and f blocks in third periods onwards, this will lead to significant effects on the properties of elements. In addition, the presence of all three types of elements, metals, metalloids, and non-metals, bring diversification in chemistry of this element. Okay. So in addition to this, in p blocks we will find there are metals, there are non-metals, there are metalloids also. So the group 15 elements are nitrogen, phosphorus, arsenic, antimony, and bismuth, and there is last one is the moscovium. So these are the group 15 elements, and among these group 15 elements there are metals. We will find metalloids, and we will find non-metals also. The non-metals are the nitrogen and phosphorus, and the metalloids are arsenic and antimony, and the metals are bismuth and moscovium. For your kind information, moscovium is not present in that amount, and they have short half-life. So due to this property, chemists and scientists don't use moscovium. Okay, that much. Okay. So in the second part, it's written that having learned the chemistry of elements of groups 13 and 14 of p block of periodic table in class 11, you will learn the chemistry of elements of subsequent groups in this unit. So already we have learned the chemistry, means we have learned about the group 14 and 13 and 14 elements, but in this unit we will learn about the group 15 to group 18 elements. Subsequent group means after this group. So after 13 and 14 group, there are 15, 16, 17, 18. Okay, so we will learn about this group. So group 15 includes nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium, that I've already said. So there are group 15 includes nitrogen, phosphorus, arsenic, antimony, and bismuth. As we go down the group, there is shift from non-metallic to metallic through metalloid characters. So as we go down the group means nitrogen, phosphorus, arsenic, antimony, bismuth. As we go down the group, we will find there are non-metals characters to metalloids characters through metalloids. Means we have first non-metals character, then we will have metalloids character, then we will have metals character. That are the typical metals. So who are non-metals? Nitrogen and phosphorus are non-metals. Then arsenic and antimonies are metalloids, and bismuth and moscovium, that is MC, is considered as typical metals. They are considered as typical metals. Now let us read about the occurrence of group 15 elements. I am reading NCERT only. You can open your book and you can see I am telling the page number 170. Okay, so in page number 170 you can find what I am reading, means I am reading the NCERT lines. So now the occurrence, let's read about occurrence. So molecular nitrogen comprises 78% by volume of the atmosphere. So molecular, let us read about the occurrence of nitrogen. So nitrogen in earth crust. Okay, in earth crust we'll find that molecular nitrogen consists of 78% by volume, not by mass. 78% by volume. Okay, so by volume. In earth crust, it occurs as sodium nitrate, that is NaNO3, and is called as child salt petri. So child salt petri is formula is NaNO3, and it is the sodium nitrate. And what is the, and another thing we can find, that is the potassium saltpetre, that is KNO3. Okay, yes, it is written in the earth crust. It occurs as, so in the earth crust it means the nitrogen. So in the earth crust nitrogen occurs as sodium nitrate, that is NaNO3, called the child saltpetre, and the potassium nitrate, that is the Indian saltpetre. Potassium means KNO3. Potassium means K and nitrate means NO3. So potassium nitrate. It is found in the form of proteins in plants and animals. So nitrogen is found in the form of proteins in plants and animals. So nitrogen is very, very important because it is found as in the form of proteins in plants and animals. Phosphorus occurs in minerals of apatite family. Okay, so phosphorus, let us now, the second element of the group 15 is phosphorus. And let us read about phosphorus. So phosphorus occurs in minerals. So nitrogens occur in the form of protein and phosphorus occurs in the form of minerals. And it forms in the minerals in the of the apatite family. And what is the formula of apatite family? That is Ca9PO6. Ca9PO4 6 dot CaX2, and X indicates here, we all know that X means the halogen, but here halogens here X means the fluorine, chlorine and OH. Okay, so phosphorus occurs in minerals of apatite family, that is Ca9PO4 6.CaX2, and that is X means the fluorine, chlorine and OH, not halogen. Okay, not all halogens. It includes fluorine, chlorine and OH. Examples of fluoroapatite. So here the apatite family's formula is written, and another example is given, that is fluoroapatite. So fluoroapatite is the apatite family, but when fluorine is added in the place of X, it will termed as a fluoroapatite. So fluoroapatite means Ca9PO4 6.CaF2, which is the main components of the phosphate group. So fluoroapatite is the main component of the phosphate group. Phosphorus actually occurs in minerals in the form of apatite family, and that formula is Ca9PO4 6.CaX2, and X indicates the fluorine, chlorines and OH. But the main components of phosphate rock is fluoroapatite. So fluoroapatite formula will be, fluoro means there will be fluorine. So in place of X we will write F, right? So the result will be Ca2PO4 whole 6.CaF2. Yes. Phosphorus is an essential constituent of plants and animals matter. Phosphorus is present in bones as well as living cells. Phosphorus are present in milk and eggs. So phosphorus is an essential constituent of plants and animals. So phosphorus is very important. Essential means very important. So phosphorus is very important components of plants and animals. So in animals, phosphorus is present in bones and as well as the living cells. Phosphorus are present in milks, phosphoproteins, I think. Not phosphorus is present, but phosphorus is present in the form of phosphoproteins. Phosphoproteins is present in milks and eggs. Arsenic, now let's read about arsenic, antimony and bismuth. So arsenic, antimony and bismuth are found mainly as sulfide minerals. So arsenic, antimony and bismuth, they are found in the form of minerals, and they are sulfide minerals. Okay, So moscovium is very important. Moscovium atomic number is 115 and its atomic mass is 289. So moscovium is a synthetic radioactive element and its symbol is Mc. Its atomic number is 115 and the atomic mass is 289 and its electronic configuration is written in NCERT, and you can do that by your own because I cannot show you. If I have to show you, then I have to do it in copy and pen. So 5F, let me say Rn, 5F14, 6D10, 7S2, 5P3. So that is the electronic configuration. Sundiru and moscovium have short half-life and their availability is very little amount and its chemistry is not yet established. Okay, so its chemistry its chemistry is not yet established, okay, by the scientist or chemist. So moscovium atomic number is 115, its atomic mass is 289 and it has short half-life and it is found in very little amount because so due to this property means due to short half-life and they are not found in enormous amount. So that's why chemist didn't chemistry is not yet its chemistry is not yet to be established. Okay. So chemist and scientists did not till now not find its what can be said. This line is very important. Its chemist is not really established. Its uses is not found by any chemistry or scientist. So except moscovium, important atomic and physical properties of other elements of these groups along with their electronic configurations are given in table 7.1. So you will find 7.1 table, that is the atomic and physical properties of group 15, and we have to memorize this all because question may come. Okay, so question may come from these and you have to memorize the value also. I have memorized in the morning. Okay, so what is the atomic number of nitrogen? The atomic number of nitrogen is 7. Atomic number of phosphorus is 50. Atomic number of arsenic is 33. Atomic number of then antimony will be 51. Then atomic number of bismuth will be 83 and atomic number of moscovium is 115. Atomic mass of nitrogen is 14.01. Atomic number of phosphorus is 30.97. Atomic number of arsenic is 74.92. And atomic number of Hb is 121 point something. What is that? Let me see this. 121.75. So atomic number of arsenic is 74.92. That is 74.92. Atomic number of Hb is 121.75 and atomic number of bismuth is 208.98. 208.98. So atomic number of nitrogen is 14. Atomic number of phosphorus is 30.97. Atomic number of arsenic is 74.92. Yes, I've said it right. Atomic number of I've said but arsenic, then antimony will be 121.75 and atomic number of bismuth will be 208.98. Now the first ionization enthalpy of group 15 will be nitrogen, then phosphorus. So nitrogen greater than phosphorus, greater than arsenic, greater than antimony, greater than bismuth, and then moscovium. So ionization, second ionization enthalpy will be nitrogen, then arsenic, nitrogen, then phosphorus, then arsenic, then antimony, then bismuth, then nitrogen, phosphorus, then arsenic, then bismuth, then antimony. Similarly, for ionization enthalpy of ionization means ionization enthalpy of group 15, that is ionization enthalpy, third ionization enthalpy of group 15. Third ionization enthalpy of group 15 will be phosphorus, nitrogen, then phosphorus, then arsenic, then bismuth, then antimony. Okay. So the covalent radius and its covalent radius unit is picometer. And covalent radius of nitrogen is 70, then phosphorus is 110, and arsenic will be 121. For Hb will be 141, then 148. So nitrogen will be 70, phosphorus will be 110, Arsenic will be 121, Hb will be 141, and Bi will be 148. So covalent radius of nitrogen is 70. For nitrogen is 70, phosphorus is nitrogen is 70, phosphorus is 110, and arsenic will be 121, Hb will be 141, then bismuth will be 148. Now the electronegativity will be electronegativity of nitrogen is 3.0, electronegativity of phosphorus will be 2.1. Yes, electronegativity of arsenic will be 2.0, electronegativity of then arsenic and antimony will be 1.9, then electronegativity of bismuth will be 1.9. Then the melting point of for nitrogen is 63, and 63 there one symbol is given, that is star like. So it is molecular, it should be molecular, that indicates molecular nitrogen. So 63 for phosphorus 317, and for arsenic 1089, for Hb that is 904, for bismuth there will be 544, and for boiling point of nitrogen will be 77.2, phosphorus 554, arsenic 888, Hb will be 1860, for bismuth will be 1837. Now the densities of nitrogen, phosphorus, arsenic, and Hb and Bi order will be for nitrogen, then phosphorus, then arsenic, then antimony, then bismuth. Okay. Now, the trains of the atomic and physical and chemical properties of groups are discussed below. So let me drink water. Wait for a minute. Sorry. So the trains of the atomics and physical and chemical properties of the groups are given below. So the electronic configurations. Now let us read about electronic configuration of group 15. So valence shell configurations of elements is, the valence shell configuration of element is ns2 and np3. So ns2 means 2 indicates the electrons. So here ns2 means s orbital has 2 electrons, so it is full filled. Then np3, and np3 p orbitals have 3 electrons. So 3 electrons means the half filled electrons of p orbital, right? So as we know, the full filled and half filled electrons of any orbital gives them stability. So similarly, this case happen that the s orbitals in this element is completely filled and the p orbitals are half filled, and this making their electronic configuration extra stable. Okay, so that's why from group Group 15 is group 15 elements having extra stability because they have full filled s orbitals and half filled p orbitals. Yes. So the atomic and ionic radius, the covalent and ionic in particular state radii increase in size down the group. So as we go down the group, their atomic radius and ionic radius will increase. These are considerable increase in covalent radius from nitrogen and phosphorus, but however, for arsenic to bismuth, only small increase in covalent radius is observed. So for nitrogen to phosphorus, there will be considerable increase of atomic size, but from arsenic to bismuth, there will be small size increasing of atomic radius. So this is due to the presence of, and the reason is also given in NCERT, and this is due to the presence of completely filled d or f orbitals in heavier elements. So why they are having this kind of atomic why they are having this considerable increase in covalent radius and small increase in covalent radius. This is due to the presence of completely filled d orbitals or f orbitals in the heavier members. Okay. So the main important thing is that nitrogen to phosphorus there will be considerable increase in atomic size, and for arsenic to bismuth there will be small increase in atomic size. Which chapter is this? This is the P block element, and its unit is 7. It's from class 12. Now the ionization enthalpy decreases down the group due to gradual increase in atomic size. The one short trick is that atomic size is inversely proportional to ionization enthalpy. Ionization enthalpy means the amount of energy needed to take the electrons from the outer orbitals. Okay. So more the atomic number, less will be the ionization enthalpy. Less the atomic number, more will be the ionization enthalpy. So ionization enthalpy decreases down the group due to gradual increase in atomic size. So as we know, the atomic size increases, means the radius increases as we go down the group. Like when we go from nitrogen to phosphorus, phosphorus to arsenic, arsenic to antimony, and antimony to bismuth, then bismuth to moscovium, their atomic size increases. Though their atomic size increases, their ionization enthalpy will decrease. Due to extra stability of half-filled p orbitals, electronic configurations, and small size, ionization enthalpy of group 15 is greater. Group 15 element is much greater than that of group 15 elements in corresponding period. So ionization enthalpy means the energy required to take out the electrons from the outer orbital. So group 15 elements already have extra stability. They have extra stability due to full-filled p orbitals and half-filled s orbitals. So due to their extra stability, group 15 elements having more ionization enthalpy than group 14 elements. Okay, and extra stability, and their first one is that about the electronic configuration. Second reason will be the smaller size. Second reason will be the smaller size. First one will be the extra stable half-filled p orbital electronic configuration, and second will be the smaller size. And due to this reason, the ionization enthalpy of group 15 element is much greater than that of group 14 elements in the corresponding period. The successive order of ionization enthalpy is expected delta IH1 less than delta H2 and delta H3. So ionization enthalpy means the energy required to take out the electrons from the outer orbitals. So when we take out the one electrons from the outer orbitals, we need some energy. And again we have decided that let us take the another electrons from that orbitals. So the energy needed will be more. Similarly, when we decided to take the electrons, means another electrons from that orbitals, their energy will be more. So energy will be more. So ionization enthalpy will be more in third ionization enthalpy, right? So similar that thing is written. Now electronegativity. Electronegativity value is generally decreases down the group with increase in atomic size. Okay, electronegativity value is decreases down the group. So electronegativity value decreases down the group as the atomic size increasing. So electronegativity value is generally decreases down the group with increase in atomic size. However, amongst the heavier elements, the difference is not that much pronounced. The electronegativity of nitrogen is 3.0, and electronegativity of phosphorus is 2.1, and electronegativity of arsenic will be 2.0, and electronegativity of arsenic will be 1.9, antimony will be 1.9, and electronegativity of bismuth will be 1.9. So that's why it's written that, however, amongst the heavier element, the difference is not much. Difference is not that much pronounced. All the elements of these groups are polyatomic. So all the elements includes the nitrogen, phosphorus, arsenic, antimony, and bismuth. Dinitrogen is diatomic gas, while dinitrogen is diatomic gas. So except nitrogens all exist in the form of solid, but nitrogen will exist in the form of diatomic gas, and phosphorus, arsenic, and antimony, bismuth, they will exist as solid, and moscovium also will exist in the form of in solid form. And moscovium atomic number is 115 and its atomic mass will be 289. Metallic character increases down the group. Nitrogen and phosphorus are non-metals. So nitrogen and phosphorus are non-metals, and then arsenic and bismuth, they are metalloids. And sorry, nitrogens and phosphorus, they are non-metals. Then arsenic and antimony, they are metalloids. Then bismuth and moscovium, they are metals. This is due to decrease the metallic character increases down the group. Nitrogen and phosphorus are non-metals. Arsenic and antimonies are metalloids, and bismuth is a metal. This is due to decrease in ionization enthalpy and increase in atomic decrease in ionization enthalpy. The boiling point is generally increases from top to bottom in the group, but melting point increases from arsenic. Then the decrease up to bismuth. The boiling point in general increases from top to bottom in the group, but melting point increases up to arsenic and then decreases up to bismuth. Except nitrogen, all elements will show allotropy. So boiling point increases from top to bottom, but the melting point increases up to arsenic. That means nitrogen, phosphorus, then arsenic. Melting point increases, then it decreases from uh, Sb to bismuth. Okay, except nitrogen, all elements are allotrophic. Now the oxidation states of group 15 elements are: nitrogen oxidation state is 5, phosphorus oxidation state is +5, arsenic oxidation state is +5 and +3. Then bismuth arsenic, then antimony's oxidation state will be +5 and +3. Bismuth oxidation state will be +5 and +3. Okay, now it's done. Now the group 15 hydrides are, NH3. NH3 common name is ammonia and its IUPAC name will be amine. PH3 common name is phosphine and its IUPAC name will be phosphane and it is colorless. ASH3's common name is arsenic trihydride and its IUPAC name will be arsine. For SbH3, its IUPAC name will be a normal name will be antimony trihydride and its IUPAC name will be stibine. And for BIH3, its IUPAC name is its normal name is bismuth trihydride and its IUPAC name will be bismuthane or bismuthine. Group 15 elements show inert paired effect. Okay, lower the oxidation number, there will be more stability due to the inert pair effect. In chemistry, p-block elements are diversified because p-block elements manifest in the reaction, manifests the ability to react with the elements of S block, G block, and F block, and they can react with themselves also. Its valence means the last orbital's electronic configuration NS2 NP126 except helium, and helium electronic configuration is 1s2. Those who are new, please subscribe my channel. So the basic maths. We'll read about trigonometry, then basic maths. What is infinity? Infinity is a relative term. Small fixed number. So what is infinity? Infinity is a relative term because it has no fixed number. So 1 meter is infinitely large in compared to radius of atoms. Radius of atom is 10 into 10 to the power minus 10 meters, or that is 10 into 10 to the power minus 10 meter, or 1 Armstrong. So 1 Armstrong equal to 10 into 10 to the power minus 10 meter. So what is infinity? Infinity is a relative term because it has no fixed number, and 1 meter is infinitely large in compared to radius of atoms. So 1 meter is infinitely large in compared to radius of atoms. Radius of atoms equal to 10 to the power minus 10 meter, that is 1 Armstrong, and 1. So it can be said that 1 Armstrong equal to 10 into 10 to the power minus 10 meter. So 1 meter is larger than 10 to the power minus 10 meter. Radius of an atom is 10 to the minus 10 meter. So 1 meter is infinitely small in compared to the radius of the earth. So 1 meter is infinitely small as compared to the radius of the earth, and radius of the earth will be 6400 kilometer. So 6400 kilometer is very larger than 1 meter. So 2 to the power 2 means 2 into 2 into 2, that is 4. 2 to the power 3 means 2 into 2 into 2, that is 8. 2 to the power 4 means 16. Okay, now 2 to the power, so a to the power n into a to the power m equal to a to the power m plus n, a to the power minus n equal to 1 by a to the power 1 by a to the power n. A to the power minus n means 1 by a to the power n. That is example like this. A to the power minus 3 equal to the power minus 3 equal to 1 by 2 to the power 3. So 2 to the power minus infinity will be 1 by 2 to the power infinity, that is 1 by infinity, and in physics it will be 0, and in mathematics it will be undefined. 2 to the power minus infinity equal to 1 by 2 to the power infinity, and that is answer will be 1 by infinity will be, and 1 by infinity is 0. So in physics we say that 1 by infinity equal to 0, and in mathematics we say that 1 by infinity equal to undefined. So what is the value of E? E value is 2.71. So e to the power infinity will be 2.71 to the power infinity, and that will be infinity will be infinity, means our result will be infinity. Now e to the power minus infinity will be 1 by e to the power infinity, and the result will be 1 by infinity and equal to 0 for physics, because we are reading physics. E to the power 1, e to the power 0 will be 1, because e to the power 0 will be 1. Similarly, 2 to the power 0 will be 1, 500 to the power 0 will be 1 also. E to the power 1, e to the power 1 equal to 1, e to the power 2 equal to e into e, and e to the power 3 equal to e into e. So e value is 2.71, so we can write 2.7, e to the power 3 equal to 2.71 into 2.71 into 2.71. Now it try trigonometry. Trigonometry includes today we'll read sin theta, cosec, tan theta. Now let us read about the concept arc. Arc means the arc length, and its formula will be arc theta. Here r is the radius and theta is the angle. So ডাইরেক্ট যদি কোনো ফর্মুলাতে থিটা থাকে তাহলে ওই থিটাকে রেডিয়ান হবে। So if theta is directly used in formula, then we have to take that theta in radian. So arc equal to radius into theta. So theta will be arc by radius, arc length by radius, and its unit will be, so theta's unit will be unitless because length indicates that its unit will be in meter, and radius is also indicating the distance only, so its unit will be in meter or centimeter. So theta will be unitless and theta will be dimensionless also. Theta's SI unit is radian. Yes. Arc length is directly proportional to theta. Now let us read the introduction of physics of chapter 1, electric charges and fields. Page number is 1. Chapter is 1. Yes. Page number is also 1. Chapter is also 1. Okay, so introduction. All of us have experienced of seeing a spark or hearing a crackle when we take off our synthetic clothes or sweater, particularly in dry weather. This is almost inevitable with ladies' garments like a polyester sarees. Have you ever tried to find any explanations for this phenomena? Another common example of electric discharge is the lightning that we see in the sky during thunderstorm. We also experience the sensations of electric shock while opening the door of a car or holding the iron bar of the bus while sliding from our seat. The reason of these experiences is the discharge of electric charges through our body, which were accumulated due to rubbing of insulating surfaces. So these things happens, we get electric shock because discharge of electric charge through our body which were accumulated due to rubbing of the insulating surfaces. You might have also heard that this is due to generation of static electricity. So static means what? It is written in NCERT only. Static means anything that doesn't move or change with time. So static means anything that doesn't move or change with time, and electrostatic means it will deals with the electrons. So electrostatic deals with the study of force, study of field, study of potentials arising from the static charge. Okay, so once again read the introduction part. All of us have the experience of seeing sparks or hearing a crackle when we take off our synthetic clothes or sweater, particularly in dry weather. This is the most inevitable with the ladies' garments like polyester sari. Have you ever tried to find any explanations of this phenomena? Another very common examples of electric discharge is the lightning that we see in the sky during thunderstorm. We also experience the sensations of electric shock either while opening the door of a car or holding the iron bar of a bus while sliding from our seat. So, what is the reason behind these experiences? The reason behind these experiences are actually there are discharge of electric charges through our body which were accumulated due to rubbing of the insulating surfaces. You might have heard that this is due to the generations of static electricity. Okay, so we might have heard that this is due to the generations of static electricity. This is precisely the topic we are going to discuss in this and the next chapter. The static means anything that doesn't move with time or change with time. Anything that doesn't move or change with time. So electrostatics deals with the study of force, study of field, and then potentials arising from the static charges. Electric charge. Historically, the credit of discovery of the fact that amber rubber with a wool or silk attracts light objects goes to Thales of Miletus in Greece around 600 BC. Then the name electricity is coined from the Greek words electrons, meaning amber. Many such pairs of materials were known, which on rubbing attracts the lightning objects like straw, peat balls, and the balls of papers. You can perform the following activities at home to experience such an effect. Cut out. So these are the experiments given. Okay. So what is electric charge? It is given that historically the period of discovery that one of the fact amber rubbed with the wool or silk clothes. These things are written in my notes very properly. Ampere and Faraday supported this observation by saying that electric charge in motion produce magnetic field and moving magnet generate electricity. Although the charged particle in motion exert both electric field and magnetic field, in the frame of reference where all the charge at rest, the force are purely electrified. That means there are three states of charge. First one is the charge should be at rest. Second one is the charge moving with constant velocity. Yes, constant velocity. That means charge is moving slowly, and the charge is moving in accelerated manner. So when the charge is moving with constant velocities, it will produce electric field and magnetic field. These are the effects of the charge. Now, when the charge is moving in accelerated manner, it will produce the effects electric field, magnetic field, and EM wave. And when the charge is at rest, it will produce electric field only. The source of charge is electrons. The source of charge is electrons. The charge is denoted by Q. The SI unit of charge is coulomb. The CGS unit of charge is ESU. 1 coulomb equal to 3 into 10 to the power 9 ESU. 1 ESU equal to 1 by 3 into 10 to the power minus 9 coulomb. Smallest unit of charge is ESU, that is Franklin, and the largest unit of charge is Faraday, that is Faraday, not Farad. Farad is the unit of Farad is the unit of capacitor. Charge is a scalar quantity, means we can add or subtract. Then charge is quantized. That means the charge can neither be created nor be destroyed, but it can be transferable. Charge is constant in an isolated system. Charge is quantized. Charge is conserved. Charge is quantized means it should be available. It should be in fixed amount. It should be in integer. And integer includes 1, 2, 3, 4, 5, 6, 50, 60, 100, etc. And the formula is Q equal to NE. Q means the charge of any body. N means the integer number, and E means the charge of an electron. And charge of electron is 1.6 into 10 minus 19 coulomb. Here we will take the magnitude. So a question is given like this: find the charge on body plus 8 into 10 minus 18 coulomb. So if we put the formula Q equal to NE, so N will be Q by E, and N is the charge of any body. So charge of any body is given in the questions only, that is plus 8 into 10 minus 18 coulomb. So N equal to Q by E, that is plus 8 into 10 minus 18 by E means 1.6 into 10 minus 19 coulomb. The answer will be 50. So 50 is an integer. So when there is an integer, obviously the charge will flow. Charge cannot flow when N value is in fraction. So fraction like 1.2, 3.2, 5.2, 6.7, but a body can have charge if it is fraction, if its fraction value is higher, like 6.5 into 10 to the power 12, 7.5 into 10 to the power 19, then we can say that body has charge. And charge, consider a question is given like this: find the charge on electron, find the charge on 6.5 into 10 to the power 12 electrons. So the charge will be the minus 6.5 into 10 to the power 12 into 1.6 into 10 to the power minus 19 coulomb. So if another question is given like this: find the charge on 6.5 electrons. So the charge will be 0. But if its fraction value is higher, like 6.5 into 10 to the power 12, then we can say the charge will be 6.5 into 10 to the power 12 into 1.6 into 10 to the power minus 19 coulomb. Okay. Now electrostatic force. So the SI unit of force is Newton, and the CGS unit of force is Dyn. 1 Newton equal to 10 to the power 5 Dyn. 1 coulomb equal to 1 by 10 EMU. Okay. The source of charge is electrons. There are two types of charge. First one is positive, second one is negative. So when a body has given many charge, means when a body is given many electrons, that indicates that graining of electrons, means when a body has grained some electrons, or when a body is having excess of electrons, that indicates that the body will have negatively charged. And negatively charged in means there will be increase in mass number. So charge are of two types. First one is positive, second one is negative. So negative charge means excess of electrons, negative charge means graining of electrons, negative charge means addition of electrons, and addition of electrons, that indicates that mass number will be increased. Now for positive charge, so from a body, if we take out the electrons, and it can be said that there will be loss of electrons, then that body will acquire positive sign. So positive signs, according to book, it will be deficiency of electrons. So when there is deficiency of electrons, the body will acquire positive charge and their mass number will decrease. Okay, their mass number will decrease. So charge are of two types, positive and negative. Positive charge means deficiency of electrons, negative charge means excess of electrons. Positive charge means mass number will increase. In negative charge, positive charge means mass number will decrease, because we are removing the electrons, so that's why mass number will decrease. And for negative charge, the mass number will increase. To find the net charge, we have to consider electrons, protons and neutrons. So the charge of one electron is minus C, that is minus 1.6 into 10 to the minus 19 coulomb. The charge of a proton is plus C, that is plus 1.6 into 10 to the minus 19 coulomb. Charge of a proton, charge of a neutron and charge of a positron is their charges are same. Charge of protons, charge of charge of protons, charge of neutrons and charge of positrons, their charges are same, and that is plus C, that is plus 1.6 into 10 to the minus 19 coulomb. Charge of electrons and charge of a proton is also same, because the sign, that is the charge of an electron is plus, the charge of an electron is minus C and the charge of a proton is plus C. So here their signs are different. So their signs indicates the property, it doesn't indicate the value, that's why their charges are same. Now charge is a property, charge is a physical property. Why it's a physical property? Because it's not visible. So charge is a physical property, and though charge is a property, obviously it will have effects. So we can say that if there is a property, there will be effects, and the properties examples are charge, mass, etc. So charge is a property, obviously it will have effects, and its effects are electric fields, magnetic fields and EMF. Mass is also a property, so mass effects will be gravitational force, then moment of inertia. So what is the formula of gravitational force? The formula of gravitational force will be F equal to G m1 m2 by r square. The formula of moment of inertia will be I equal to m r square. If a question come like this, if a body has property, then it will have gravitational force. If a body has property, then it will has gravitational force. If a body has property, it will has gravitational force. And another statement is, if a body has mass, it will has gravitational force. So first statement is, if a body has property, it will have gravitational force, and second statement is that if a body has mass, it will have gravitational force. So both the statements are correct, because mass is a property. So instead of mass, property is written in the first statement, and second statement instead of property, mass is written. So both are same. So both the statements are correct. So if there is no property, there will be no effect. If there is no property, there will be no effect. So let us read about insulators and conductors. You can open the page number 5 of NCERT. And in today's thing, I will say, what is a conductors, what is an insulator? Conductors means, when conductor means a materials or a electric material that allow the electricity to flow, that is the conductor. Okay, and what is insulator? And this thing we have read in class 6 or 7, right? So what is insulator? The materials that doesn't allow the electricity to flow. So the conductors allow the electricity to flow. So there will be flow of electricity. So flow of electricity means there will be flow of charge, and flow of charge means there will be flow of electrons. So when there is flow of electrons, there is a flow of charge, and flow of charge means there will be flow of current. So when current flow, if there is a flow of electrons, and flow of electrons means there will be flow of charge, and flow of charge means there will be flow of current. Conductors have free electrons, and free electrons are allowed to move freely, and they will move freely inside the conductor. So conductors are allowed to move freely inside the conductors. And if we give excess charge to a conductor, then that charge will reside on the surface of the conductor. So excess charge can be positive and negative charge. So that charge will reside on the entire surface of the conductor. That means that that charge will be distributed to the entire surface of the conductor. Entire surface, not in one place. That charge will be distributed to the entire surface of the conductor. Now, what is written in NCERT? Another thing is written, like conductor has low resistance. So from the Ohm's law, we can say V equal to IR. So I is inversely proportional to 1 by R. So when there is low resistance, their current will be maximum. So resistance means the obstacle. So when the obstacle is minimum, the current will flow maximum. Conductor has high thermal stability and they will have positive temperature coefficient. Examples are aluminium, metals, humans, etc. Now, insulators are opposite of conductors, means insulators and conductors are opposite. Insulator means there will be no free electrons, their resistance will be maximum, they will not allow the current to flow. So from the Ohm's law, B equal to IR, I is inversely proportional to R. In insulator, resistance is maximum, so current will flow minimum, means no current will flow. So when we give excess charge to our insulator, that charge will remain at the same place only. There will be no flow of free electrons in the insulator. Okay. So if some in NCERT it is written that in para 1, 2, 3, third para it is written that when some charge is transferred to a conductor, it will readily get distributed over the entire surface of the conductor. So when some charge means the extra charge. When we add some extra charge to a conductor, it will readily get distributed on the entire surface of the conductor. Okay. In contrast, if some charge is put on an insulator, put on means given. If some charge is given to an insulator, if some charge is given to an insulator, it stays at the same place. Okay. Yes. So in first para, some examples are given, like a metal rod is held in hand and rubbed with wool. It will not show any sign of being charged. Okay, so when we hold a metal rod in our hand and we have taken wool in another hand and then we have just rubbed it, okay, they will not show any sign of being charged. However, if a metal rod with a wooden or plastic handle is rubbed without touching, so its metal part, it will show the sign of charging. So two examples are given. First one is the when a metal rod in hand is rubbed with wool and we have just rubbed, that means there is a contact between two substances. So that will not show any sign of being charged. However, if a metal rod with a wooden or plastic handle is rubbed without touching, so we have taken a metal rod and a wooden or plastic handle and we have just rubbed without touching, then the metal part will acquire some charge and there is it's written that its metal part it shows sign of charging. Now another example means that they have given the experiments. So another experiment is that we have to, let me read the inside line only. Suppose we connect one end of the wire to a neutral pit ball and another end to a negative charge plastic ball. We will find that pit ball will acquire a negative charge. So we have to take a copper wire and we have connected one end of the copper wire with the neutral pit ball and another end of the copper wire with the negative end of the plastic rod. Then we will find the result will be that pit ball will acquire negative charge. Okay, is due to the conductor. Copper is a conductor, so it will allow the flow of charge. If similar experiment is repeated with a nylon thread or a rubber band, no transfer of charge will take place from plastic rod to pit ball. Why does the transfer of charge not take place from rod to the pit ball? The charge is not transferred from rod to the ball because here the nylons and rubber is used as a medium. So nylon and rubber is the examples of insulator. So that's why charge is not flown. But in the first experiment we have used the copper wire, so that's why charge is flown. So copper wire is a conductor. Conductor means there will be flow of electricity, and flow of electricity means there will be flow of charge, and flow of charge means there will be flow of electrons. So when there is flow of electrons, there will be flow of charge and there will be flow of current. So in a conductor, current will flow, but in an insulator, no current will flow. Okay. That's why conductor is having low resistance and current will flow maximum. Conductors have free electrons. Free electrons means they are the neutral. Free electrons are neutral. So neutral body means number of protons and number of electrons are same, and their charge means the free electrons charge is 0. Yes, free electrons charge is 0. And when we give excess charge to a conductor, that excess charge will reside on the entire surface of the conductor. That excess charge will distribute it on the entire surface of the conductor. But for an insulator, if we give the excess charge, that excess charge will remain at the same place. Now in the last para, page number 5 of NCERT, it's given, when we bring a charged body in contact with the earth. So when we bring a charged body in contact with the earth, all the excess charge on the body disappears by causing a momentary current to pass to the ground through the connecting conductors such as our body. The process of sharing the charges with the earth, that is grounding or earthing. Earthing means the process of sharing charge to the earth. The process of sharing charge with the earth, that is earthing. So what is the process? The process is given when we bring a charged body in contact with the earth. So we have to bring a charged body with contact with the earth with the help of the medium. That medium is the conductors. All the excess charge of the body disappears. So when we bring a charged body in contact with the earth, the excess charge of that body disappears by causing a momentary current to pass to the ground. So all the momentary current will pass to the ground through connecting a conductor. So the medium is the conductor, such as our body. Our body is a conductor. The process of sharing charge with the earth, that is the conductor. Earthing provides a safety measures for electrical circuits and appliances. A thick metal plate is buried deep into the earth, and a thick wire are drawn from this plate, and these are used in buildings for purpose of earthing near the main supply. So earthing, actually the main fund of earthing is that it provides a safety measures to electrical circuits or appliances. We have all seen, in my home also earthing is done. Okay. So for earthing, I have seen a thick metal rod or plate is thick metal rod is that uncle has bought a thick metal rod and he has just buried inside the ground, and a thick wire is drawn from them, and this actually helps this provide the safety measures for electrical and electrical circuits and appliances. Okay. The electrical wiring, the electric wiring in our houses has 3 wires. So in our houses we have 3 wires. First one is the live wire, second one is the neutral wire, and third one is the arc. The first two carry the current from the power station. So the live wire and the neutral wire, yes, the live wire and the neutral wire carry the current from the power station. So what is written? The electrical wiring of our houses has 3 wires. So the electrical wiring of our houses has 3 wires. So what are the 3 wires? The first is the live wire, second is the neutral wire, third is the arc. That is the arc. The first 2 wires carry the current from the power station, and third wire is earth by connecting it to the buried metal plate. So earthing, that indicates the earthing. So earthing, that is the third is earth by connecting it to the buried metal plate. So the metallic bodies of electric appliances such as electric iron. The electric iron is used for spreading our clothes. Refrigerators, TVs are connected to the earth wire. So these things, because these things are very costly, TVs are very costly, a refrigerator is very costly. So these things are connected to the earth wire. When any faults occur or live wire touches the metallic body, the charge flow to the earth without damaging the appliances or without causing any injury to the human. So when any faults occur or live wire touches the metallic body, okay, so live wire actually carries the currents from the power station. So when that live wire when the live wire touches the metallic body means the refrigerator freeze like this. So when that live wire connect the metallic bodies, their charges will flow to the metallic bodies, right? Means if we have damage to the live wire, then that current will flow all over that metallic bodies. Metallic bodies means the freeze TVs like that. So this earthing helps, okay, to save this earthing helps to save us and the metallic bodies also. This would have otherwise been unavoidable since the human body is a conductor of electricity. The human body is the conductor of electricity. And another thing I have missed, that is the examples of insulator is given in NCERT. The examples of insulator is the glass, porcelain, plastic, nylon, wood offer high resistance. So the examples of non-metals. So most of the non-metals like glass, porcelains, nylons, wood offer high resistance to the passage of electricity through them. So most of the non-metals are insulators, and they are glass, nylons, porcelain, wood. Wood should be the dry wood, okay? Wood should be the dry wood. Wood should be the dry wood because wet wood has water, and um, water is a insulator, but it has many impurities. So though it has many impurities, it will allow the flow of electricity from it. So up to this physics. Let's revise biology. Biological classification. Then I will again revise chemistry, then coordination compounds, then importance of coordination compounds. For which class? For class 12, I am revising my own notes. I am a NEET dropper, so I am revising NCERT. That from physics, chemistry and biology. Actually, I am revising. I am not teaching anyone. Biological classification, chapter 2, and its unit name is the diversity in living world. Chapter 2, biological classification. Chapter 2, biological classification. The important things I will read from this. Since the dawn of civilizations, there have been many attempts to classify living organisms. Since the dawn means when the civilization started. So since the start of civilizations, there have been many attempts to classify living organisms. It was done instinctively, not using criteria that was scientific, but born out of a need to use the organisms for our own use. So earlier classification was done naturally, it was not done scientifically. So but born out of a need to use the organism for our own use. So we have done the class, means earlier we have done the classifications on the basis of our basic needs, that is shelter, clothes, food, okay. Aristotle was the earliest to attempt more scientific basis for classification. He used simple morphological characters to classify plants into shrubs, herbs and trees. So he used the simple morphological characters to classify trees, shrubs and herbs. He also divided animals into red blood and those that did not. Okay, so Aristotle was the first person who did the classification scientifically, and he used the morphological characters to classify plants. So he classified plants on the basis of trees, shrubs and herbs, and he did the classification of animals on the basis of red blood and that did not have the red blood. So those who are having red blood is known as enema, and those that did not have red blood, that is known as enema. Now the two kingdom classification was given by Linnaeus, and he included the Plantae and Animalias. The five kingdom classification was given by R.H. Whitaker, and he divided five kingdom classification as Plantae, Animalia, then Monera, Protista, Fungi, Plantae and Animalia. Okay. The system did not distinguish, the two kingdom classification did not distinguish between the eukaryotes and prokaryotes, unicellular, multicellular, photosynthetic and non-photosynthetic. Classifications of organisms into plants and animals was clearly done and was easy to understand, but a large number of organisms did not fall into either category. So classifications of organisms, that is plants and animals, was easier to classify because we can easily understand what is a plant, what is an animals. But some things were left, some things were not, some things were left. Okay, so a large number of organisms, but a large number of organisms fall into that category. Classifications of organisms in plants and animals was done and easy to understand, but large number of organisms did not fall into either category. Hence, the two kingdom classifications was used for a hence the two kingdom classification used for a long time was found inadequate. So, two kingdom classification was used for a long time because all have accepted that there is a difference between plants and animals, but there are few organisms did not fall into that category, and two kingdom classification was done for a long time, but it was found inadequate. Besides the gross morphology, need was also failed for including other characteristics like cell structure, nature of wall, mode of nutrition, habitat, method of reproduction, evolution, relationship. So beside the gross morphology, need was also felt that it should include, the classification should include cell structure, nature of wall, mode of nutrition, evolutionary relationship, and habitat. Classification system for the living organisms have hence undergone several changes over time. Though the plants and animals kingdom have been constant under different systems, the understanding of what groups and organisms be included under this kingdom have been changing. So the plants and animal classification, classification have been constant for different systems, but understanding of what groups and organisms be included under this kingdom have been changing. The number and nature of the other kingdom have also been understood differently by different scientists. R.H. Whitaker in 1969 had proposed 5 kingdom classification. The kingdom defined by him include Monera, Protista, fungi, plantains, and animalias. So let's read about Moneras. Monera is prokaryotic. Pro means primitive and karyotic means nucleus. So before nucleus, that means prokaryotic organisms. So Monera is the prokaryotic organisms. The cell type is prokaryotic, and cell wall is their cell wall is non-cellulosic, that is polysaccharide plus amino acid, and they are prokaryotic. Obviously, they don't have nuclear. They have well defined nucleus, and they don't have membrane bound nucleus also. Their body organization is cellular, and they have their mode of nutrition will be autotrophic, and autotrophic includes the chemosynthetic and photosynthetic, and heterotrophic includes the saprophytic and parasitic. Parasitic are those organisms that lives on host organism and suck the nutrition from them, and saprophytic means they actually take the nutrition from the dead matters. Okay. Now for the Protista. Protista is eukaryotic. Eukaryotics are well developed from prokaryotic, and though they are well developed, they have nucleus, and they have nuclear membrane bound nucleus also. They have membrane bound organelle also. Their their body organization will be cellular, and their mode of nutrition will be autotrophic and heterotrophic. Here autotrophic will only include photosynthetic. Photosynthetic means they do photosynthesis and they derive the nutrition from photosynthesis also only. And for Protista, few Protista have cell walls, so all Protista don't have cell walls. Now for fungi is also eukaryotic. So fungi cell wall is not cellulosic. Fungi cell wall will be chitinous and polysaccharide. Some fungi cell wall will be multicellular and loose tissue. Okay, so fungi are tissue level organism, but plant are organ level, and animals are organs and organ system level. So fungi are multicellular and they have loose tissue. Their body organization is multicellular and loose tissue, and they have cell wall. Obviously they have cell wall, and their cell wall is not cellulosic. Their cell wall is chitinous and polysaccharide. Okay, now all know about plants. So plants will be eukaryotic. Plants cell wall is cellulosic. Plants have cell walls. Their mode of nutrition will be always autotrophic. Plants can do photosynthesis, so they will be autotrophic. And what about their body organization? Their body organization will be tissue and organ. Okay, their body organization will be tissue and organ, not the organ system. Their body organization will be tissue and organ. For animalia includes the animals. So the cell type is eukaryotic. Mode of nutrition will be heterotrophic, and for animals it will be, they were holozoic and saprophytic. They are holozoic. Holozoic means, in class 8 I think read about holozoic. Holozoic means they have ingestions, means the taking of food, then they will do digestion, means they have then assimilation, absorptions, like this, that process. Okay, so that holozoic and saprophytic too. Animals are holozoic and saprophytic, and their mode of nutrition will be, I have said nutrition, so the body organization will be tissue, organ and organ system. Okay, we have organ system. Okay, now the cell wall, obviously animal will not have cell wall. So cell wall are absent in animals, cell wall are absent in amoeba, cell wall are absent in paramecium, cell wall are absent in mycoplasma. So what is mycoplasma? Mycoplasma are the smallest organism. They can survive without oxygen, and they lack cell wall. Okay, three domain system has also been proposed that divides the kingdom Monera into two domains. So Monera was done into two domain, and leaving the eukaryotic organisms in the third domain, and thereby six domain classification. Now the examples of algae are Chlamydomonas and Spirogyra. It's written in page number 17. Okay, Chlamydomonas and Spirogyra. Examples of non-photosynthetic is fungi. Examples of photosynthetic is examples of photosynthetic is green algae, and green plants also can do photosynthesis. What is the difference between the cell wall of plants and animals? Cell wall of plants are cellulosic. Cell wall of what I'm saying. What is the difference between the cell wall of fungi and plants? The difference between the cell wall of fungi and plants are their compositions. Actually, both of them have cell wall. That is, fungi and plants both have cell wall, but their compositions are different. And fungi cell wall is made up of chitin and polysaccharide, and plant cell wall is made up of cellulose. Animals don't have cell wall. Amoeba don't have cell wall. Paramecium don't have cell wall. Mycoplasma don't have cell wall. Now let's read about the kingdom of Monera. So Monera is prokaryotic. Pro means primitive. Karyotic means nucleus. So primitive nucleus. So they don't have well-defined nucleus. I think I'm reading class 8 chapter. Means in class 8 we have well differentiate between prokaryotes and eukaryotes. What is prokaryotes, what is eukaryotes? That type of questions are given, and we used to write 5 to 6 point about prokaryotes and eukaryotes, and we'll get 5 out of 5. That time scoring marks is so very easy. So Monera is prokaryotic. So pro means primitive, karyotic means nucleus. So they don't have well defined nucleus. So Monera is prokaryotic. They don't have, though they are not having well developed nucleus, only how they can have a membrane bound nucleus. So they will not have membrane bound nucleus. Their mode of nutrition is autotrophic, that is saprophytic, autotrophic, that is chemosynthetic and photosynthetic, and their mode of nutrition will be heterotrophic also. Heterotrophic includes parasitic and saprophytic. So bacteria are the sole members of kingdom Monera. and they are the most abundant microorganism. Abundant means they are found in large number, so they are the most abundant microorganisms. Bacteria are occur almost everywhere, so they can survive in everywhere, means every situations. Every situations means in the harsh extreme conditions. So they, though they can survive, that means they have some specialty, and that specialty will be they have high metabolic rate, right? Yes, they have high metabolism, that's why they can survive in harsh habitat. Hundreds of bacteria are present in handful of soil. So in if we take one handful of soil, we find hundreds of bacteria. They can live in extremely harsh habitat like hot spring, desert, snow, and deep oceans, where very few other life form can survive. Yes, obviously, in extreme harsh habitats, very few life form can survive, but bacteria can survive in harsh habitat because they have extensive metabolic rate. Many of them live in or on other organisms as parasite. Many of them can live in or on other organisms, and that includes the parasite. Parasite actually lives on the host organism and they draw the nutrition from them. Bacteria are grouped under 4 categories based on their shape. So bacteria are grouped under 4 categories based on their shape. So what are they? They can be spherical shape, and in singular form means the bacteria who is having uh, see a spherical shape, it is termed as coccus, and its plural form will be cocci. For rod shaped bacteria, is termed as bacillus, and in plural form it will be bacilli. For comma shaped bacteria, it will be cocci for singular, and plural will be coccus. Coccus for comma shape. What's written? Coccus. Coccus is the spherical. Sorry. For the comma shaped bacteria, it for singular will be Vibrio. So singular will be Vibriums and plural will be Vibrio. For the comma shaped bacteria, its singular form is Vibrium and plural form will be Vibrio. And for spherical spiral shape, for the spiral shape, the bacteria is termed as Spirilla, Spirillum, and for plural form it will be Spirilla. So the singular form will be Spirillum, plural form will be Spirilla. So let me say this point once again. Bacteria are grouped under 4 categories based on their shape. There are 4 shape of bacteria. First one is the spherical shape, second one is the rod shape, third one is the comma shape, and fourth one is the spiral shape. So the spherical shape bacteria singular name is coccus, and plural form will be cocci. And for rod shape is termed as bacillus, and its plural form will be bacilli. Comma shape Vibrium, and its plural form will be Vibrio. And spiral shape bacteria is termed as Spirillum, and its plural form will be Spirilla. Though the bacterial structure is very simple, they have complex behavior. Compared to many other organisms, bacteria as a group show the most extensive metabolic diversity. Some of the bacteria means few bacteria are autotrophic and maximum bacteria are heterotrophic. So what's written? Some of the bacteria are autotrophic, and autotrophic means they synthesize their own food from inorganic substrates like carbon dioxide, inorganic substrates like water. Then they use sunlight, okay, from the raw materials, and they may be photosynthetic autotrophic, chemosynthetic autotrophic, and heterotrophic. So the mode of nutrition of bacteria are chemosynthetic autotrophic, photosynthetic autotrophic, and heterotrophic. So the vast majority of the bacteria are heterotrophic. Vast means abundant. So the vast majority of bacteria are heterotrophic. They depend on the organisms or on dead organic matter. So they depend on the organisms or on dead organic matter. So they depend on the organism, that is parasite. and or on dead organic matter for foods, that is the saprophytic. I am already saying that heterotrophics are of two types, parasitic and saprophytic. Parasitic means they depend on the dead organic matter, and saprophytic means they depend on the dead organic matter, and parasitic means they depend on the organisms. Now for archaebacteria, let me drink water. Let's read about archaebacteria. These bacteria are special because, so there are two types of bacteria. First one is the archaebacteria, second one is the eubacteria. Eubacteria are also termed as true bacteria. And for archaebacteria, they are the special since they live in some of the harsh habitats. So they are special because they can live in the some of the harsh habitats that are halophiles, thermoacidophiles and methanogens. So halophiles means they can survive in salt areas. Then hot spring means thermo means what? Heat. So hot spring, the thermoacidophiles live in hot spring and methanogens live in marsh areas. So these bacteria are special since they live in some of the most harsh habitats such as the extremely salty areas that are halophiles, hot spring that are thermoacidophiles and marsh areas that are methanogens. Archaebacteria differ from other bacteria. So what is the specialty of archaebacteria? Why they are different from other bacteria? Archaebacteria differ from other bacteria in having a different cell wall structure. So they are having different cell wall structure. That's why archaebacteria are different from the other bacteria. And this feature is responsible for the survival of the extreme conditions. So this feature means different cell wall structure. So archaebacteria have different cell wall structure. That's why they can survive in extreme conditions. Methanogens are present in the gut of the ruminant animals. So who are ruminant animals? The ruminant animals are cows, buffaloes, ox, etc. Ruminant animals are those animals who can digest cellulose, means they have the capability to digest cellulose directly. And they are responsible for the productions of methanogen, that is methane, that is the biogas only from the dung of the cows. Now let's read about eubacteria. There are thousands of different eubacteria. So there are thousands of different eubacteria. Eubacteria are termed as true bacteria. So it is written that there are thousands of different eubacteria or true bacteria. They are characterized by presence of rigid cell wall. So eubacteria have rigid cell wall. And if motile, if means all eubacteria are not motile. So if they are motile, they have flagella. So actually we know that flagella helps in motility, means they can move. So if eubacteria or true bacteria have flagella, they can show motility. The cyanobacteria also referred to as blue-green algae. They have chlorophyll A, similar to green plants, and they are photosynthetic autotrophs. So cyanobacteria are the blue-green algae. What is the other name of cyanobacteria? The other name of cyanobacteria is blue-green algae. They are having chlorophyll A, similar to and chlorophyll A. So cyanobacteria are similar to blue-green algae, and they are photosynthetic autotrophs. The cyanobacteria are unicellular, colonial, and filamentous. So the cyanobacteria are unicellular, means they are cellular. They only have one single cell. So cyanobacteria are unicellular. They can be colonial. Colonial means we know what is colony. So they are unicellular. They can form colonies, and they live in colonies, and they can be filamentous. And they will live in fresh waters / marine waters or terrestrial water. Not terrestrial means the land. It's my slip of tongue. They can survive in terrestrial bodies. They can survive in freshwater and marine. The colonies are surrounded by gelatinous sheath. In page number 19, if you open, then you will find the figure 2.2. Okay, and we'll find that they have glutinous sheets. That is the blue color is given in NCERT. So that is the mucilaginous sheet. Okay. The colonies is generally surrounded by glutinous sheet. Thus, they often form blooms in polluted water bodies. They are the mucilaginous sheet. This blue color is the mucilaginous sheet. So filamentous green algae picture is given in figure 2.2, and this indicates figure 2.2, and they have they are heterocyst, and why heterocyst is present is given, and mucilaginous sheet also given. They often form blooms in polluted water bodies. Some of these organisms can fix atmospheric nitrogen in specialized cells, and they are heterocyst. So some of the organisms of cyanobacteria can fix nitrogen in special cells. They are heterocyst, and examples of heterocyst are nostocs and anabina. So examples of cyanobacteria can be nostocs and anabina. Chemosynthetic autotrophic bacteria can oxidize inorganic substrates. So what are the inorganic substrates? The inorganic substrates are nitrates, nitriles, and ammonia. What is the formula of ammonia? In box we have read. Ammonia is the hydride form of 15 group 15 elements. Ammonia is the hydride form of group 15 elements, and ammonia means NH3. So trihydride is added with ammonia. So normal name of NH3 is ammonia, and its IUPAC name will be amine. They use the released energy for ATP production, and they play a great role in recycling nutrients like nitrogen, phosphorus, iron, and sulfur. Heterocyst bacteria are most abundant in nature. It is written in first only that autotrophic bacteria are very less and heterotrophic bacteria are abundant. So heterotrophic bacteria are most abundant in nature. Most of them are decomposers. Many of them have significant effects on human affairs. Examples: they help in making curd from milk. They are used in they are used in antibiotics. Okay, and they help in fixing nitrogen in the legumes root. So some of the pathogens causing damage to human beings also, and crops and farms, animals and pets. So some of them are pathogens and causing damage to human beings, crops, farm, animals and pets. Animals diseases means bacteria cause animal diseases, that includes cholera, typhoid, tetanus, and plant diseases, citrus canker. So plant disease, citrus canker, as well as are well-known disease caused by different bacteria. So the bacteria that cause animal disease are cholera, typhoid, and tetanus, and plant diseases caused by citrus canker. Bacteria produced mainly by fission. So bacteria, there are two type of reproduction shown by bacteria. So bacteria shows two type of reproduction. They reproduce mainly through fission, and when they can reproduce with the help of the spores during unfavorable conditions. So during unfavorable conditions, they reproduce with the help of the spores. They also can show sexual reproduction also by adapting primitive type of DNA transfer from one bacteria to another. So they transfer DNA from one bacteria to another, and that is the primitive type of DNA transfer. So this form is known as sexual reproduction in bacteria. Mycoplasma are the organisms. They are the smallest organisms. They can survive without oxygen. They don't have cell wall between them, and many of the mycoplasma are pathogenic in both plants and animals. Now let's read about Protista, and in Protista I will revise up to chrysophytes only. Now let's read about Protista. Who are Protista? Who are Protistas? Protistas are prokaryotic organisms. As I've already said, pro means primitive and karyotic means nucleus. So primitive nucleus. So they don't have well developed nucleus. They will have nucleoids. So they don't have well defined nucleus. Obviously they will not have membrane bound organelle or membrane bound nucleus also. So they will not have membrane bound nucleus, membrane bound organelle. They are primitive, they are prokaryotic, their mode of nutrition is Autotrophic, that includes chemosynthetic and photosynthetic. Their mode of nutrition will be heterotrophic, and that includes saprophytic and parasitic. They are cellular. They have, yes. What I'm saying, I'm saying the characters of Monera. Sorry, I'm saying the characters of Monera. Okay, let me see the characters of Protista. What I've said about Protista before, please cancel that. I've said the characters of Monera. So Moneras are prokaryotic. They are cellular, and their mode of nutrition is autotrophic and heterotrophic. Autotrophic includes the chemosynthetic and photosynthetic. They are cellular. What about Protista? Protista is eukaryotic, and eukaryotic means they have well-defined nucleus. So they have well-defined nucleus. Um, Eukaryotes have well-defined nucleus. So they have membrane-bound nucleus. They have membrane-bound organelle. Their mode of nutrition will be autotrophic, that includes photosynthetic, and heterotrophic will also be include. Or heterotrophic is also the mode of nutrition of Protista, and heterotrophics include saprophytic and parasitic. Okay, let me read what is written in NCERT in page number 20. All the single-celled eukaryotes are placed under Protista, but the boundaries of these kingdoms are not well defined. In this book, we include chrysophytes, dinoflagellates, euglenoids, slime molds, and protozoans under Protista. So Protista are of 5 types. You can memorize like this: C, D, E. We know that A, B, C, D, E. So take write from C, D, E. C for chrysophytes, D for dinoflagellates, E for euglenoids, and then write S, P. So S for slime molds, and P for protozoans. Members of Protista are primarily aquatic. These kingdoms form a link with other dealing with plants, animals, and fungi. Being eukaryotes, Protista cell body contains well-defined nucleus. Other membrane-bound organelle, they have flagella and cilia. Protista reproduce sexually and asexually by the process cell fusions and zygote. So Protistas have well-defined nucleus. They have well-defined organelle. Protistas can reproduce sexually and asexually. They reproduce asexually with the cell fissions, and they reproduce sexually with zygote formation. Now let's read about chrysophytes. This group includes diatoms and golden algae. And golden algae, desmids are known as the golden algae. So another name of golden algae is desmids. The desmids are known as golden algae. They are found in freshwater as well as marine environment. They are found in freshwater. They are microscopic and float passively in water currents that are planktons. They are microscopic. They are small and float passively in water currents. Most of them are photosynthetic. In the atoms, the cell wall form two thin overlapping cells which can fit together as in the soap box. The walls are imbued with silica, and thus the cell wall are indestructible. So why they are indestructible? Indestructible means they cannot be broken easily because they have silica, and they have two thin overlapping cells which can fit it into the soap box. And Protista and chrysophytes includes diatoms and golden algae. Golden algae, desmids are also known as golden algae. They are found in freshwater as well as marine environment. They are microscopic and float passively. There is planktons, and in diatoms the cells from two thin overlapping cells. In diatoms, the cell wall form the two thin overlapping cells which can fit into the soap box. Their cell walls are embedded with silica, and due to silica, they cannot be broken easily. Indestructible. Thus, diatoms have left behind large amount of cell wall deposit in their habitat, and the accumulations over billions of overs led to the diatomaceous arc. Okay, so diatoms have left behind large number of cell wall deposits in their habitat, and these accumulations over billions of years, okay, or their accumulations over billions of years is referred to as diatomaceous art. Being gritty, this soil is used in polishing, filtration of oils and syrup. So diatomaceous art is used in filtration, diatomaceous art is used in polishing of oils and polishing of syrups. Diatomaceous are the chief producers of oceans. Diatomaceous are found in chief producers of oceans. Diatomaceous are not found in stagnant water also. I have revised biology up to this and I can't read anymore now. I've said I will revise chemical coordination compounds. So let us revise chemical coordination compounds, then I will take a break. So let me drink water. Few portions I will revise in chemical coordination compounds. Those who are new, please subscribe my channel. Standard potentials are 289 Kelvin. I don't want to read this. So let me revise from last. Importance and applications of coordination compounds. Okay. Importance and applications of coordination compounds. Actually, coordination compounds is used in many things. I have not found anything that is left in applications of coordination compounds. Coordination compounds are widely used in the minerals, the plants, and animals world. Okay. When I have read this, the lines, when I read the NCERT lines, the importance of coordination compounds, I found that nothing is left in coordination compounds. Means in everything we use coordination compounds. So coordination compounds are widely present in the minerals. It's present in plants. It's present in animals world. In plants means coordination compound is used present in plants. Means in chlorophyll we have coordination compounds, that is manganese. And in animals we have hemoglobin, and hemoglobin is the coordination compounds of iron. So we know that chloroplast, how chloroplast is important in plants. So chloroplast is very essential for photosynthesis, and hemoglobin carry oxygen. It is the red color pigment. Okay. So coordination compounds, the importance role in the area of analysis of in the area of analytical chemistry, then metallurgy, biological system, industrial medicine. So coordination compounds is used in medicine also. In the last para, we'll find that many coordination compounds is used in the treatment. Okay. And in the industries we use coordination compound. In the biological system we use coordination compound. In the metallurgy we use coordination compounds. In the area of analytical chemistry we use the coordination compounds. Coordination compounds find uses in qualitative and quantitative chemical analysis. So coordination compound find uses in many qualitative and quantitative and quantitative chemical analysis. So how the color retention form? When there is a chelating ligand, so chelating ligand plus metal ions form the uh, coordination entity. Here the coordination entity means the compounds. It forms the basic for the detections and estimations of ions by chemical and industrial method of analysis. Examples EDTA. Another example is dimethyl dioxin, that is DMG. Then alpha nitroso and beta naphthol, then cupron. Hardness of water can be estimated means by, yes, hardness of water can be estimated by titrations with Na2 EDTA. The group 3 elements cation, that is calcium Ca2 plus and magnesium Mg2 plus. So Ca2 plus magnesium 2 plus form the stable complex with EDTA. So Ca2 plus and Mg2 plus form the stable complex with EDTA. The selective estimations of these ions can be charged due to the difference in the stability constant of calcium and magnesium. So the selective estimations of ions can be charged due to difference in the stability of calcium and magnesium complex. These things are written in NCERT only in page number 262. What I am reading? I am reading NCERT only, and I am telling the meaning of this also. Some of the extraction process of metals include silvers and gold make the use of complex formation. So silver and gold extraction means the complex, and complex here means the coordination compounds. Coordination compounds, in coordination compounds, like, leave that one. I'm telling the new one. Like Au plus Cn, that is cyanide. So Au means the gold. Gold abbreviation means we can write gold in the symbol Au. So Au plus Cn, it with water and oxygen. So water and oxygen form the solution, means that it's the from the aqueous solution. Water is used. Water, when we use water, that means the aqueous solution. So the result will be AuCN2 minus. And from this solution AuCN2 minus, we can extract gold by addition of zinc. So when we add AuCN whole twice minus with Zn, we can separate iron from that solution. Purification achieved through formations and subsequent and the decompositions of coordination compounds. So if we want to take out the pure nickel, then what can be done? At first we have to take the impure nickel, and then we find the impure nickel only. So impure nickel is converted into NiCO4. Then it get decomposed. It will then we'll find the pure nickel. Coordination compounds are of great importance in biological system. Okay, like in chlorophyll. Chlorophyll is used in photosynthesis, and the coordination compounds used in chlorophyll is magnesium. Okay, and the coordination compound used in chlorophyll is magnesium. And for hemoglobin is the red color pigment of blood, and hemoglobin acts as an oxygen carrier, and it is used, the coordination compound used here is iron. And for vitamin B12 is found in card, right? In card it is the cyanocobalamin. It is the anti-pernicious anemic factors, and the coordination compounds of vitamin B12 will be cobalt. So the coordination compounds of chlorophyll is magnesium. Then coordination compounds of hemoglobin will be iron, and the coordination compounds of vitamin 12, that is cyanocobalamin, that is cobalt. Other compounds of biological importance with coordinated metal ions are enzymes. So what are the examples of enzymes? Enzymes are carboxylase polypeptides, carboxy polypeptidase A, carboxy polypeptidase A. So other compounds of biological importance with coordinated metal ions are enzymes, that is carboxy polypeptidase A, and second one will be carboxy anhydrase, and that is the catalyst of biological system. So carbonic anhydrase is the catalyst of biological system. Carbonic anhydrase is the catalyst of biological system. So there are two types of enzymes. First one is the carboxy polypeptidase A, that is written in NCERT only, page number I think 262. No, that is written 263. Sorry, you can open the page number 263. You can find that other compounds of biological importance with coordinated metal ions are enzymes like carboxy polypeptidase A and carbonic anhydrase, that is catalyst of biological system. Coordination compounds are also used as a catalyst. and that is used in industrial processes like rhodium complex and Wilkinson catalyst. Formula is PH3, P whole thrice RHCl, and both are used as a hydrogenations of alkenes, ALKENES, that is double bond. Alkenes are double bonded. So articles can be electroplated with silver and gold much more smoothly and evenly from the solution of complexes. So the articles can be electroplated with the silver and gold much more with the solutions like AuCN2- and AgCN2- than the other what is written, other metallic ions, right? Yes, from the other solution of simple ions, other solution of simple metallic ions. So coordination compound helps in electroplating. So here articles can be electroplated with gold and silver much more smoothly and evenly from the solution of complexes, and the solution of complexes like AuCN2- and AgCN2-, okay, from the solution of simple metal than the solution of simple metal ions. In black and white photography, the developed film is fixed by washing with hyposolutions, which dissolves the undecomposed AgBr to form the complex like AgS2O3 whole twice 2,3-. There is a growing interest in the use of chelating therapy in medicinal chemistry. An example is the treatment of problems caused by the presence of metals in the toxic proportions in plants and animal system. Thus, the excess of coppers and iron can be removed by chelating ligands, and the chelating ligands are D-penicillamines and D-ferroxime B via formation of coordination compounds. EDTA used in the treatment of lead poisoning, and some of the coordination compounds of platinum effectively inhibit the growth of tumors. Example, cisplatin and other related compounds. So tumors can be inhibited with using the compounds uh, platinum, example cisplatins and other related compounds. And the copper and irons can be removed by the chelating reagent like D-penicillamines and desferoxime B. Desferoxime B. EDTA used in treatment of lead poisoning. EDTA is used in the treatment of lead poisoning. And in the summary, 264 page, two points are also written. Coordination compounds are of great importance, written in the last para. These compounds provide critical insight into the functioning and structure of lot vital compounds of biological system. Coordination compounds also find extensive applications in metallurgy, analytical and medicinal chemistry. Bonding in metals carbonyl. Bonding in carbonyl compounds. So for bonding in carbonyl compounds, we need metals, and that metals have 5 orbitals. 5 orbitals. Which metals are 5 orbitals? Transition metals are 5 orbitals. So they are the d block elements. So d block elements means the d orbitals are d shape or double dumbbell shape, and they have 5 orbitals. 1 orbital is vacant and 4 orbital is fulfilled. For the carbonyl compounds, carbonyl C has one lone pair. So one lone pair means there will be 2 electrons, and a bond is formed with the help of 2 electrons. Here pi antibonding orbitals is present. So for bonding we need metals and we need carbonyl compounds. So for the metal carbon sigma bond, Okay, so when there is a bond, we have already read double bond. So in double bond, we will find one sigma bond and one pi bond. For triple bond, we will find one sigma bond and two pi bond. Similarly, there is a bonding and we will find sigma bond and pi bond both. So metal carbon sigma bond is formed by donation of one lone pair from the donation of one lone pair means there will be two electrons. So donation of two electrons or donation of one lone pair from the carbonyl compounds to the vacant orbitals of the metal. Okay, and it forms the sigma bond. So sigma bond is formed when there is head-on overlapping. Though there is head-on overlapping, it will form the sigma bond. For the metal carbon pi bond is formed when there is sidewise overlapping. So sigma pi bond is formed when there is a donation of one lone pair. Again, lone pair means there will be two electrons. So donation of two electrons or donation of one lone pair from the fulfilled d orbitals of the metal to the carbonyl compounds pi antibonding orbitals, and there is sidewise overlapping and back donation pi bond, and there is sidewise overlapping and back donation pi bond, and these donations of electrons from metals to the pi antibonding orbitals of carbonyl compounds means from the metals electrons are transferred to the pi antibonding orbitals. So electrons are transferred means electrons are donated in the pi antibonding orbitals. So in the pi antibonding orbitals electrons are increasing. So what is the formula of bond order? The formula of bond order is Nb minus Na, that is Nb minus Na by 2. Nb means antibonding orbitals, Nb minus Na by 2, that equal to means in antibonding we are giving in carbonyl compounds metal is giving electrons. So antibonding in antibonding pi orbitals electron is increasing. So the bond order will decrease if we put the formula Nb minus Na by 2. So the result will be in negative. So that's why the bond order is decreasing. Is written, and this will create an effects, and these effects will be the synergist effect. And this will create an effect, and that effects will be the synergic effect, and it strengthens the bond between CO and the metal. The ligands are present between acid pi ligand, and the ligands are known as the acid pi ligand. So acid pi ligands are formed when there is vacant antibonding pi orbitals. Carbonyl compounds in synergic effects, the carbonyl compounds will be C triple bond O, and CO is the carbon monoxide. CO can be the carbon monoxide, CO can be the acid pi ligand, CO can be the strong field ligand. So what are the examples of weak field ligand? The weak field ligands are halogens and water. Halogens means the fluorine, chlorine, bromines and iron. Applications of synergic bondings, it is due to the synergy applications of synergic bondings due to the synergic bondings and charging densities on metals. So the metal carbon bond, for the metal carbon bond energy increases, bond order increases, bond length decreases, and it's opposite to the carbonyl compounds means CO bond energy decreases, bond order decreases and bond length increases, and the charge densities will be charge densities for metal carbon bond is negative greater than neutral. Neutral means 0, greater than positive. And for the CO bond, the charge densities order will be positive greater than 0, greater than negative. Synergic bonding has length and they have minimum difference. So if a question is given like this, if a CO bond length is CO, if a CO bond length in one Yes, if our CO bond in CO is 1.128 Armstrong, then what is the value of CO bond length in FeCO5? So I've already said that the synergic bonding has bond length and they have very minimum difference. So after finding the value, we'll find that the value will be similar to the 1.28, means more than 1.128. Okay, more than 1.128, but it should not be larger value than the 1.128. So the options are given 1.15, 1.128, 1.72, 1.172, then 1.118. So answer will be the 1.15 Armstrong. Compare the CO bond strength. So for finding the bond strength, the three compounds are given like MnCO6 2 plus. What is the structure of MnCO6? There are 6 ligands. So the structure will be the octahedral. So CrCO6, 3 CrCO6 and another is VCO6 negative. So you have to find the oxidation number, and I have already said about the charge densities of carbonyl compounds. So charge densities of the order of charge densities of carbonyl compounds will be positive, greater than 0, greater than negative. So for MnCO6 oxidation number is 2 plus, so Mn2 plus. For CrCO6 oxidation number is 0, so Cr has no charge, and VOCO6 oxidation number is VCO6 minus is there, so oxidation number is -1. So Mn2 plus Cr then V. So what is the order of the charge densities on CO bond will be first greater than second greater than third. Okay. Organometallic compounds. So what is organometallic compounds? Split the word organo, split the word metallic, and split the word compound. So organo deals with the organic, and organics is related with the carbon. Metal will be the transition metal here. The compounds in which metal is directly bonded with the carbon, that is the organometallic compounds. So the compounds in which the transition metal here will be the transition metal. So the compounds in which the compounds in which the transition metal is directly bonded with the carbon, that is the organometallic compounds. There are two types of organometallic compounds. First one is the ionic organometallic compounds, and second one will be the covalent organometallic compounds. So ionic metallic organomcompounds, ionic organometallic compounds. So ionic means ions. Ions are of two types, cations and anions. So ionic bond is present between the metals and carbon. Ionic organo means organic, and organic deals with the carbon. So there is a ionic bond between the carbon and the metal. As the heading is that ionic organometallic. Metallic means the transition metals. So ionic bond is present between the metals and the carbon. Covalent organometallic compounds. So covalent bond means there will be sharing of electrons, and sharing of electrons means there will be sharing of two unpaired electrons. We can share the electrons, that there will be the unpaired electrons. So covalent bond are present between the metals and the carbon. As the name from the heading, we can say that covalent organometallic compound. So the covalent bond will present between the metals and the carbon. Covalent bonds are of three types: sigma bond, pi bond, and sigma and pi bond. We all know what is sigma bond. Actually, sigma bond is formed with the help of the single bond. When there is single bond, there will be sigma bond. And single bond means there will be two electrons, because a single bond is formed with the help of the two electrons, and that electron should be the unpaired electrons. Sigma bond is present between the metals and carbon. Example: CH4SN, CH3 whole twice 4 SN, CH3 whole twice 4, CH3 in bracket 4, CH3 bracket 4, then SN. SN means the team. Okay. Now if we want to find out the number of sigma bond between the metals and carbon, in the example, CH3 bracket 4 means there are tetramethyl. So CH3 is the methyl group. So 4 in number. So methyl group is 4 in number. So tetramethyltene. So the number of sigma bond between the tetramethyltene will be 1, 2, 3, 4. 4. Because we have to find the sigma bond between the metals and the carbon. RMGX is the Grignard reagent. RMGX is the examples of the covalent organometallic compounds. So RMGX. So what are the number of sigma bond present in RMGX? So the number of sigma bond will be 5 sigma bond. For Al2 Me6, Me is also termed as methyl group, and Al2, Al is the aluminium. So there are 2 aluminium. Number of sigma bond will be 8. Now for the pi bond. Pi bond is donated by double bond. Okay, so when there is double bond, there will be 1 pi bond and 1 sigma bond. When there is triple bond, there will be 1 pi bond and 2. When there is triple bond, there will be 1 sigma bond and 2 pi bond. When there is single bond, there is 1 sigma bond and 0 pi bond. Ferrocene. So what is the formula of ferrocene? Fe bracket. Fe will be means write Fe in third bracket, then give the first bracket, write n to the power 5. Yes, Fe n to the power 5 C5H2 whole twice, and close the third bracket. So hapticity here will be 5. Hapticity means number of carbon in ring and the linear chain. So hapticity will be 5. For dibenzene chromium, so dibenzene means there will be 2 benzene, and chromium is the transition metals, that is Cr. So Cr n to the power 6 Cr. So give the third bracket, then write Cr, then give the first bracket n to the power 6 C6H6, close the first bracket, give whole twice, then close the third bracket. So hapticity of dibenzene chromium will be 6. And for this salt, the formula is K, in third bracket write PgCl3, give the first bracket, write n to the power 2 C2H4, close the each bracket, then its hapticity will be 2. Hapticity indicates the N. So what will be the number of N, what will be the N value? It will be the hapticity, and hapticity means the number of carbon in a ring or the linear chain. Now for sigma and pi bond, it occurs between the metals and carbonyl compounds. For example, NiCO4. Now NiCO4 hybridization will be NiCO4. So the ligand is 4 in number, and its shape will be the tetrahedral, and its hybridization will be sp3. MnCO5, its hybridization will be dsp3. Its shape will be the trigonal bipyramidal. And for FeCO5, its shape will be the trigonal bipyramidal, and its hybridization will be the dsp3. For CrCO6, ligand number is 6, it will be octahedral, and its hybridization will be D2sp3. For MnCO10, that is Mn2CO10, decacarbonyl dimanganese. For decacarbonyl dimanganese, it will form 2 square bipyramidal, 2 square pyramidal, and it has no bridge bond. Okay, there is no bridge bond, and yes, it has no bridge bond. Okay. For CO2 CO8, it has 2 bridge bond, so number of bridge bond will be 2, and its hybridization, no need of hybridization. Okay, it will be 2 tetrahedral unit. What is mononuclear, what is dinuclear, what is trinuclear, what is tetranuclear? Mono means 1, nuclear means metal. So when there is 1 metal, there will be, it is termed as mononuclear. So the definition will be when 1 metal is connected with the one type of ligand. So when 1 metal is connected with the one type of ligand, that is the mononuclear. And for dinuclear, when 2 metal, di means 2 and nuclear means metal. So when 2 metal is connected with the one type of ligand, that is termed as dinuclear. When the 3 metal is connected with the One type of ligand, it is trinuclear. When the four metal is connected with one type of ligand, it is termed as tetranuclear. Homoleptic carbonyl compounds. Okay. So first, let us know about what is homoleptic and what is heteroleptic. When a coordination compound has one type of ligand, that is homoleptic complex. Example PTCl4. So here the ligand is Cl only, that is chlorine, but Cl is 4 in number. So don't consider that Cl is 4 in number, it is homoleptic. Homoleptic means there will be one type. Type means what are the ligands? Ligands examples are chlorine, fluorine, bromine, right? So when there is one type of ligand, it is known as homoleptic complex, and heteroleptic complex means when a compound have more than one type of ligand, that is heteroleptic complex. Example PTNH3 whole twice Cl2. So the ligands here two types. Type 1 is NH3, that is amine, and Cl2, that is chlorine. So ligands here 2. So ligands type is 2, and metal is 1, and metal is the Pt, that is the platinum, and palladium is the transition metal. Now what are the examples of weak field ligand? The weak field ligand examples are halogens and water, that is fluorine, chlorine, bromine, iodine. They are the weak field ligands, and water is also the weak field ligand. And strong field ligand examples are CO, NO, NH3. Okay. So when for the tetrahedral complex, the ligand number will be 4. Okay, and their shape will be tetrahedral. So for the octahedral complex, its ligand number will be 6. So it will be the octahedral complex. Now for homoleptic carbonyl compounds. So when the homoleptic carbonyl compounds means only carbonyl ligand is related with these homoleptic carbonyl compounds. Homoleptic carbonyl compound is formed by most of the transition metals. Homoleptic carbonyl compounds have simple and well defined structure, and here only one type of carbonyl ligand is used, that is CO. Examples of homoleptic carbonyl compounds are, and I will say their formulas, their oxidation number, their structure and shape. So for homoleptic carbonyl compounds, examples are tetracarbonyl compound, that is NiCO4, ligand number is 4, its shape will be the tetrahedral, and oxidation number is 0, and its structure will be the tetrahedral. For pentacarbonyl iron, so FeCO5, so its shape will be trigonal bipyramidal, and oxidation number is 0. For hexacarbonyl chromium, that is CrCO6, its shape will be octahedral, and oxidation number is 0. For decacarbonyl dimanganese, its formula will be M into CO10, means the decacarbonyl dimanganese. So 2 manganese is there, so its structure will be like this, Mn. Let me write in graph copy. Mn. So here CO, then CO, then. So there is no bridge bond is present between decacarbonyl manganese. Can you say that the coordination compound present in chlorophyll is magnesium. The coordination compounds of hemoglobin is iron, and the coordination compounds of vitamin B12, that is carboxylamine. What is it? I must talk about it. Cyanocobaltamine, that is cobalt. So here there is 2 bridge bond. So number of bridge bond will be 2. Limitations of crystal field theory. So crystal field theory actually successfully explain about the properties of coordination compounds, and the properties are formation, structure, magnetic properties and color. In the crystal field models, there is ligand, and ligand act as a point charge. As a result, anionic ligands fluorine, chlorine, iodine, iodines and chlorine should exert the greatest splitting effect. What is anionic ligand? The ligand actually are formed at the lowest end, The anionic ligands actually are found at the lowest end, and lowest end means the left side of the spectrochemical series. Anionic ligands does not take account of covalent characters. Covalent character means there will be sharing of electrons, and sharing of electrons means there will be sharing of two electrons, and the two electrons should be the unpaired electrons. Consider an atom having 1s2. 1s2. So 1 here is the principal quantum number, and 2 is the electrons. 2 are the electrons. So for s orbitals we are having 2 electrons. For p orbitals we will have 6 electrons. For d orbitals we will have 10 electrons. For f orbitals we will have 14 electrons. That's what we are reading. Now, anionic ligands are some of the weakness of CFT, which can be explained by ligand field theory and molecular orbital theory. So, bonding in metals, we have read about bonding in metals. So, for bonding in metals, there is bonding, that is the double bond metal should be the transition metals, and carbonyl compounds means there is a bond between carbon and oxygen, and the bond should be the double bond, but for the synergic effects the bond should be the triple bond, that's C triple bond O. For the synergic effect it will be C triple bond O. Okay, and here it will be C double bond O. So I have revised chemistry. So I'm coming, wait for a minute. Up to this I will revise. Thank you those who are with me. Thanks a lot. So I'm switching off the screen. I will not do live anymore. So thank you.